So, real quick, let's go back to what we know. So, today's notes, let's see, what's the date? 125, right? 18, I think. 125:18, right? We've seen this before. So if the bases are the same, these are the bases, then you can just add the exponents. So you go 4 to the add of 6 plus 4 is 9, right? So you just add them. So we have a rule. Here's our rule, and we learned this rule in algebra that if you multiply the same bases, you add exponents, right? Okay. What you're really familiar with is x's. If it's x squared times x cubed, you know that's x to the 5th, right? Thumbs up, everybody agree? You've seen that before, right? This is nothing new, right? Nothing new at all, okay? Same thing with division. When you divide the same bases, you subtract. This really is like 4 times 4 times 4 times 4 times 4 times 4. I do this with Landon. 4 times 4 times 4 times 4 times 4 times 4 over 4 times 4 times 4. And the reason you subtract the x goes those cancel, those cancel, those cancel. So how many do you have left? 3 of them on top. You see how it works? But it's much easier to say I'm just going to subtract exponents than write them all out. Cancel, cancel, cancel. You agree? Writing them all out is kind of a pain. Much easier to just say, okay, well, I'm just going to go 6 minus 3. Okay, so then you get a rule, which again, this is an algebra rule, which you've seen before, okay? Here's your algebra rule. If you divide the same bases, right, you subtract exponents. So you guys have seen it as far as x. If I have x to the 8th over x to the 5th, it's just x to the 3rd, right? You guys agree with that? We've done that, okay? Thumbs up, algebra stuff, right? Jesus, you with me? Thumbs up. You guys have done this before. This is easy. Agree? Okay. If you don't know this, then you probably didn't learn anything in algebra, and I feel bad for you because I guess I put you behind the ball, huh? Okay. Now, when you take an exponent to an exponent, you multiply, okay? You multiply, right? And let me show you an example why. So if you had, just a really easy example, if I had x squared cubed, right? One way to do this is to write x squared times x squared times x squared. That's kind of a pain, right? Which is 2, 4, 6 of them, right? But it's so much easier to say, I'm not going to do that. I'm not going to write it out. X squared, x squared, x squared. That's a pain, right? I'm just going to multiply exponents. I know that I'm going to have an x to the 6, right? Everybody agree with that? So we have a rule. Exponent to an exponent, we just multiply the exponents, right? Again, algebra stuff. Now, the next example, we've got 3 times 2 to the 5th, right? 2 ways to do this. One, I could just make this a 6. I can make this a 6 to the 5th. Or I know the 5 go to the 3 and the 5 goes to the 2. It goes to both, right? And so then you get the 3 to the 5th times 2 to the 5th, okay? So in algebra, here's our rule. We know that if you've got 2 things to a power, you can give it to both, okay? All right. Same thing with a fraction, right? If you're going to take a fraction to a power, the power goes to both, right? So this is just review of algebra. Everybody agree with that? Okay. Thumbs up. Everybody agree with this? Okay. This is just review. So turn the page, all right? So the power. So in your words, what's the power? Give me in your words. What's the power mean? The power. The power.
How many times that number is going to be multiplied by itself?
Nice. Luke said, how many times that number is going to be multiplied by itself? Nice job. Okay, how many times that number is multiplied by itself? Nice, good answer. So that means the exponent is the power, right? Isn't the exponent the power? The exponent is the power, right? So it's the number that tells us. It's the number, it's the little number, right? The exponent's the little number. Now the base is the big number being multiplied, right? The base is the big number being multiplied, right? Okay, we can skip scientific notation because I'm going to talk about that later, okay? You can skip scientific notation, okay? Okay, now, 0 power. This is really weird, but trust me. Anything to the 0 power is always 1. Anything, okay? So let's check it out. Let's see what our calculus is, okay? All right, Emma, give me a number, any number. 8. Come on, clear. 8 to the power of 0. Wow. Okay. Golly, come on now, let's get this thing so it doesn't. Hold on. Yeah, 8 to the. Can you see that okay? Let me get this here closer. Get this closer. Ah. Can you see it yet? Man, this glare's bad. Oh, there we go. Now I can see. Okay. Jesus, put your phone away and give me a number. Any number. 5 to the 0 power. Okay. All right. Bella, give me a number. Give me a good number, huh? 2 to the power of 0. Okay. Yes.
984.
To the 0 power. 1. 100 pink elephants. 100 pink elephants to the 0 power. 1. Always 1, okay? So, let's go back to this. So, anything, any number to the 0 power is always going to be 1. Always, okay? Now, negative exponents, okay? Here's what I really want to talk about today, okay? So, anything to a negative exponent, okay? Ready? Listen. When you see negative exponents, think two things. One, I want you to think first, what you think of fraction. Okay? So whenever you see negative exponents, I want you to think fraction. And then I want you to think, move it to make it positive. Okay? Move it to make it positive, all right? So, first thing they did on their example is they made a fraction bar. And then they brought it down. Okay? If you got a negative exponent, it's on the wrong side, you just move it down. Now, when they move it down to a 4 to the 2, yes, what goes on top? You have to have something on top. You put a 1. Okay? Now, let me pass out the next piece, and let's do some practice, okay? There we go. Let's do some practice. All right? 1, 2, 3, 4, 5, 6, 7, 8. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? Back.
Bro, it sounds really bad. How crazy. Like this amplified back here.
Pass those back, and we're going to practice, all right? Pass those back, and we're going to practice, okay? Everybody have one? Okay, real quick. Question number 1. What's the answer? Everybody agree? 1. Boom. Easy peasy lemon squeezy. Answer number 2. Bam. How hard can this be? Now number 3. Am I going too fast?
Yeah.
Okay, anything to 0 power, 1, right? Okay, it is 1 over 3 to the 4th. Who said that? That was right. 1 over 3. Yeah. But 1 over 3 to the 4th is a great answer. I would take that. But what is 3 times 3 times 3 times 3? 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Or 1 over 81. Okay? All right? This one is 1 over negative 4 to the 3rd, right? So, negative 4 times negative 4 is 16, times another negative 4 is a negative 64. Does that make sense? great question. Let's see if they show one that makes a difference, okay? So, okay, the reason it's in parentheses is we have to cube the negative. So we're going to go the negative 4 times negative 4 times negative 4. Real quick, a great example. Let me show you an example. Who asked that question about the parentheses? Okay. Katie, was that you?
Yes.
Really good. So actually, it was a great question. Check this out. Look at the difference. I want to do two problems. 1 over 2 negative 2 squared or 1 over negative 2 squared. Okay. Katie, you asked a great question. This answer is negative 1/4. Because the negative wasn't in the parentheses and negative didn't get squared. This one is going to be 1/4. Now, your calculator will do the same thing. Katie asked a great question. So, with the parentheses, we're going to square the negative, okay? So, even the calculator will agree with me, okay? So, real quick, if I go, can you see the calculator? If I do negative 2 squared, right? Now, we know negative 2 squared, wouldn't you think negative times negative? Boom. It thinks it's negative 4. But if I go parentheses, negative 2 squared, it says positive 4. So, Katie, you asked a really good question. With the parentheses, we have to square the negative. Without the parentheses, you don't square the negative. Does that make sense? Okay.